Today we will review the lecture 10, Logistic Regression, 11, Neural Network, and the method to handle the time series. And everyone lecture has one assignment. So you finish this and submit next week. Logistic regression. Logistic regression a little different with the linear regression. The linear regression model data using continuous numeric value, but the logistic regression models the data in binary values. Actually, in the examples we studied in the multiple linear regression, you can also convert critical variable to dummy variables. Yeah. So both methods can support the binary variables. The linear regression is to express the linear relationship among dependent and independent variables. But the logistic regression will not have to build this relationship. The logistic regression will use the one logic function, odds function, and probability function to estimate the possibility for the output. So output will be the binary, yes or no. In a linear regression, the independent variable can be correlated with each other. But in a logistic regression, the variable must not be correlated with each other. That's why we need to use the binary values for the data. We need to convert the critical value to dummy variables. Okay, this is the table for the comparison. The linear regression will be just one straight line for the model. Logistic regression will be one probability function. Actually, it's one log function, log curve. Also, you can say it's one linear function of the combined predictor variables for the git function. For the JIT function. Okay, the logistic regression actually you can say is based on the linear regression model method, but we apply the linear regression method into creation of the logic function. Then we continue to create the probability function. And we create the output as one binary variables. This logistic regression can be widely used in a situation to predict or explain one phenomena. The output will be just one binary classification, 0 or 1. Yeah, we already said this. So this is the import statement used in a Python. The logic function is one function of the predictor variables. And this will be further to use to create the probability function with a binary value. So we will not use one predictor, one variable for the outcome variable, which is used by the linear regression model. Here we will use one function of the outcome or logic function to be used for the calculation of the probability for the output. Logic function is one linear function of the predictors. The logic function can be mapped back to probability and in turn mapped to a class. A probability is for one outcome value, whether belong to 1 or 0. The probability is one value between 0 and 1. We can express the relationship between the probability and the predictors using this linear function. This is used for the linear regression model for the output. And y, you can just replace p to y. The next one equation is for the logistic regression function. And the kernel beta 0 plus beta 1 s1 until beta q sq can be called logic function. So that we have the other one definition for the arts function. Arts function is equal to the probability divided by 1 minus probability. This is equivalent to the next one. That inverse the input probability to be the output. Arts will be the variables. So that we can obtain the arts expression to be exponential at power beta 0 plus beta 1 s1 beta q sq. Because this can be derived from the two equations, the time 4 and time 2. And from these two, we can realize this result for the arts function. Then we can have the logic function. It's log value over arts value. A log function over the arts value, equivalent to the beta 0 plus beta 1 s1 beta q sq. Actually, the arts function will be this exponential curve. The logic function will be this one curve. So the logic function is one linear function of the predictors S1, S2, etc. Okay, here the example for the data personal loan offer. The outcome variable is one binary variable to accept bank loan or not. So the value can be 0 or 1. The predictors include demographic information and other information about their bank relationship. The table shows the raw data with multiple fields. Before the application of logic regression modeling, we can make the data pre-processing. We can create a dummy variable from the categorical predictors. We will divide the data into two groups. And also we obtain several dummy variables, edu, professor, edu, grade A, and also the other four dummy variables, securities, CD, online, credit card. You can see from the raw data, the education has only 3 possible values, 1, 2, 3. So we can convert this categorical variable into 2 dummy variables as edu professor, edu grade. And for the security, there are only 2 values. So its own already dummy variable. Here is a single predictor model. We will use just one predictor. So the probability function, the personal loan is yes, for the income is x. It's equal to 1 divided by 1 plus e exponential negative bracket beta 0 plus beta 1 x. So then we can use this model to train the system using the training data. And we can obtain the coefficients beta 0, beta 1 for this equation. Then we have this trained results for the probability function. And it can be displayed with one curve. This is a probability function. It has one range, change the probability from 0 to 1. Then we can use this model to classify any input. The input can be the training data, it can be validation data. And we also define one cutoff value for the classification. If the probability is larger than cutoff value, it will be classified as 1. Otherwise, it will be 0. Usually, we use 0.5 for the cutoff value. We can also take other consideration for this different cutoff value according to several considerations, maximizing classification accuracy maximizing the sensitivity, minimizing false positives, minimizing the expected cost of misclassification. Estimation of the beta versions are derived from iterative process. We call this process as one maximum likelihood estimation. So the more predictors with more questions will need a longer computation. Here's the code. We track the data from universal bank.csv file. Then we remove two fields, ID, zip code, because these two fields are not useful. Then we replace the blank character with underline character for the field name or variable name or predictor name or outcome name. Then we convert the education clerical variable to be dummy variable. Firstly, we need to define the education variable to be clerical variable. Then we have new categories with 3 possible values. Then we rename the predictor education clerical variable with a different name, undergraduate, graduate, advanced, and professional. Then we convert the clerical variable education to dummy variables. And we have the prefix separator on the line at the beginning. Then we create the Y for the outcome variable that corresponds to the variable personal loan. The other columns will be the predictors, X. Then we divide the data into 2 groups, training data set and a validation set. The validation set ratio is about 40%. Then we define logistic regression model with a penalty value to be 12, the C value to be 1E42. The solver is a live linear. Then we call the fit function to train the model using the training data. Then we build one data frame using the questions, train the results of the questions, the questions of the training results, the logic regression question, or logic regression questions in the fourth field, the name corresponding to the column names for the individual variables. And then we transpose to display the results. Then we calculate IRC score for the validation data and for the predicted results for the validation data. These are the results. We can obtain the intercepts. It's about -12.6. And we also receive the questions for the logic function. Yeah, the age variable has questions -0.032549, etc. The IC score -709. Yeah. Okay, this is the probability function derived from the odds value. And this is the prediction for the validation data. And next will be the predicted probability value for the validation data. Then we build one data frame using the actual value for the validation data and logic regression probability value P0, P1. And the last one is predicted value from the linear logic regression model. Then we can choose 4 cases. And we can use these 4 cases. Yeah, we'll firstly print the logic results for these 4 cases. So we can see the predicted result for the 4 cases. Yeah, predicted probability and predicted value. So the 0 is for this case because the P0 is larger than P1. The next one case 932, the actual value is 0, but we predict as a 1. So it's a wrong prediction because this 1 from the P1, its value is 66.5%. The last one is also wrong prediction. Yeah. Actual value is 1, but we predict 0. Because the probability to be 0 is 98.6%. The predicting the outcome variables is based on the trained logistic regression system, logistic regression model. And the predictive classification is based on the cutoff value for the probability function. And according to the choice of the cutoff value, we can explain the results in a different way. Okay, we increase S1 by 1 unit and holding the other predictor not change or constant. B1 is a factor by which the odds of belonging to class 1 increase. So we can explain the dependency of the outcome on individual predictors. Or we can also evaluate the performance using the confusion matrix. We call this classification summary function to obtain this confusion matrix. You can further to derive the accuracy and error rate and other factors from this confusion matrix. We can also derive the gain or lift plot according to the classification results. Yeah, because we can index or order the cases according to the probability. Yeah. The high ability cases will be put in the beginning. And then we can plot the gain chart and the lift chart. Okay, this is the result for the gain chart. Yeah, we call the lift chart function. Okay, before this, we need to sort the data according to the probability values for case 1. Yeah, the 1 is to accept the bank offer. Okay, then we call the gain chart function using the actual value. Yeah, because this is already sorted actual value, so we can obtain the gain charts. The next one function to create the lift chart. Here we will use the probability 1 value. Then we create this lift chart. Yeah, for the case 1. But there's one problem in the mathematical linearity. In the linear regression system, if one predictor is a linear combination of other predictors, the model estimation will fail. Mathematical linearity, mathematical linearity, mathematical linearity, mathematical linearity. Okay, mathematical linearity. As in a linear regression, one predictor is a linear combination of other predictors. The model estimation will fail. For this situation, we should have at least one redundant predictor. The solution is to remove the extreme redundancies by dropping the predictors via the variable selection. You can try the correlation matrix, or you can also try the PCA, principal component analysis, to reduce the number of variables. So this will be the same topic as the linear regression. The number of correlated predictors can grow when we create derived variables such as interaction terms to capture more complex relationships. So there's one problem. The complex models will have the danger of overfitting. The solution is to reduce the number of variables through the automated selection of variable subsets. Okay, this is the end of lecture. We will go to the code of this lecture. We can start an Conda navigator. And start notebook. And go to the folder where you store the code and the data. So we start the logistic regression. Okay, the code is simple. First one part will be import. We will not care. We just copy and paste that part. Then will be the example for the data universal bank. We remove two columns. Then we remove the blank character for the variable name. Then we change the education variable to be category variable. Then rename the we rename the categories name with a new name. Then we create dummy variables for this empirical variable education. Then we create two datasets, outcome and predictors. Then we obtain training data set and validation set. Then build the logistic regression model using the parameters here. Then we train this model using the training data. Then we obtain intercepts for this logistic regression model and also the questions of this logistic regression model. Then we obtain the LRC score for the validation data. Okay. Next will be the other one analysis, just using one predictor, income. The outcome variable is the personal loan, the same as before, personal loan. And also we use the two data and also the predictor variables and outcome variables, training data set and validation set, and the modeling, training, and RC score intercept parameters. So we can compare the difference between each other from two methods. The previous one we have multiple predictors. Yeah, many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 12 predictors. And this one is just one predictor income. Yeah. So you can see RC score is different. Yeah, intercept also different. Okay, next is for the calculation of the probability value. So we can apply this model to the validation data and obtain the predicted results for the validation data, and also obtain the predicted probability value for the validation data. Then we print the results, the actual outcome value for the validation data, the probability value for case 0 and 1, and the predicted results for the validation data. Okay, we just extract 4 cases for the analysis results for these 4 values. And next one is for the classification summary to create the confusion matrix. So the top one for the training data, the bottom one for the validation data. Okay, this is to create the gain chart on the left by calling the all sorted actual value according to the probability 1, case 1. Left chart is to work on the probability value for case 1. Yeah. Okay, next one is for example, the flight delays, CSV file. Here, we will work on the field is delayed. If the status is delayed, then it's 1. For other status in a variable, flight status is delayed, value is assigned to 0. So we can create one dummy variable is delayed from the column flight status. Okay, then we call the group by on one column a day week. And for this group is delayed, we calculate the mean value. Then we make a bar plot on this calculated mean for the delayed every weekday. So we can see the delay mean value for every one weekday, Monday to Sunday. The maximum delay will be Monday. Yeah. Lowest delay is Saturday. Okay, next one is for the data to obtain the data from flight delays CSV. We also need to create the is delay new variables from the flight status. Okay, then we build 2 functions: create graph and graph departure time. Create graph is to use 3 variables. A group as label axis. In the create graph function, we firstly to make a calculation of the mean value for the group which are delayed. If the group is weekday week, Then we apply the index. From Sunday, Monday to Saturday. Then we make a bar plot. For the new indexed average value of the delay. Okay, next one function is to plot, is to create one date frame with two fields, CRS departure time is delayed. And we group on the departure time for the delayed cases and calculate the average value. Then we plot these results using a bar. Next one is to create one matrix plot, three row, 2 column. The create graph is the calculation of the average delay for the weekday. Next one is plot the destination. Destination, the average delay. Then plot the departure time, average delay. Okay, then we plot the carrier, the weekday, so the carrier delay, the origin delay, average value, the weather delay, average value. Okay, next is calculate the average delay value for the 3 cases, origin, day, week, carrier. Then we reset the index. Then we use the data in the delay results according to different origin value. We will attach the carrier cases, the unique cases that are a origin for the flight. And we can create the new array, height ratios. And we also can make the subplot, 3 row, 2 column. We can create a pivot table for the grouped data according to the origin for the departure. Then we create the heat map display for this new created data. And we assign the tickle label on the x-axis with the week, Sunday, Monday to Saturday. Okay, next one is to continue work on the same data, flight delay CSV. The same to create the critical variable for the day, week, and translate the departure time into different unit by dividing 100. So it will be integer value for departure time. And convert this departure time to critical variable. Then we have the collection of predictors and y for the outcome. Then we have the income data and outcome, the predictor data and outcome data. And also the classes for the outcome. So 0 for the on time, 1 for the delayed. So it's delayed from the situation. If the delay will be assigned to 1, 0 is for the case not delayed. It's on time. 0, so it's on time. So we can have this correlation. Yeah. You can't change the sequence. Then we create the data sets for the validation and the training. Then we build the model, logistic regression, then training the data, training the model using the training data. Okay. Then we configure the display width, precision, maximum column. Then we display the intercepts and also questions for the logistic regression model, RC score for the validation data. Okay, next is for the predicted probability value for the validated data. Then we create the data frame using the 4 data, active value, possibility for 0 case, probability value for 1 case, and the predicted value, all for the validation data. Then we created the classification summary and the gain chart. Yeah, we have this. Okay. Then next will be about the same. Only difference will be here, the data frame with a new data, Sunday, Monday fields, has a value y. Or 0. Yeah, it's a weekend. Yeah. If it's a 1 or 7, then this variable will be 1, otherwise it will be 0. Okay, carrier, CO, MQ, if these 4 cases will be 1, otherwise it will be 0. Yeah, so we can create a new data using the data frame. Yeah, the others will be the same. Then we can continue the analysis. We can obtain these results. Okay, next one is to for the plot of the gain chart. Yeah, for the full results and the red results. Red results will be this new data. full result will be the previous one results using original data format. So you can see there are little difference between two analysis methods. Okay, next one is for a new analysis. We add one constant column. Then we create the predictor variable and outcome variables, and also data sets for the training and validation. Then we call the GLM model, a general linear model. Then we train this model. Then we print the results. The result will be here. So we can see the questions for everyone predictors, and also standard deviation error for the analysis. Next one is for the data accidents for.csv. Okay, we define outcome variable, predictor variables, and the data simulation, and model is logistic regression. Then we train the data and print the intercepts coefficients, all the same before. So then we print the probability value, active value, predicted value for the training data. Yeah, the training data will be the same as the original data. So there's no validation sets. Yeah, only training data. Okay, next one is to call the model logistic IT. Yeah, the ordinal logistic regression. We can also obtain the results for the probability and actual and predicted value for the data. So we can compare these two methods difference. Okay, next one is the nominal logistic regression. We'll process the same. The define outcome, a predictor, and we have the outcome classes, a logistic regression model, and we can have the value for the probability ABC. So there are 3 possible values for the output. So this is the 3 feature of the nominal, multinomial. So outcome values can be obtained from this statement. And we just sort the outcome with the different values, so we can obtain 3 possible value ABC. Here we can see the classes, the 0, 1, 2. There are 3 possible values. Yeah, so we have 3 probability for the outcome. Okay, next is the definition of function plot probabilities. So create two variables. Alcohol, okay, ALCHLI. The other one is with R. So we can use this S-test data to obtain the predicted probability values. Then we can have the results of predicted value, probability values for different cases. Then we make a plot. So we can see the plot for 3 cases. And we can see they are in different distribution. The A case is on the right top area. The B is in the middle area. The left bottom area will be for the C. So this is the similar results as the previous one. Yeah. So you can try this by your own self. But actually, we will not cover much for these examples. Okay, now we'll continue the assignments. The assignment is to ask you to analyze the financial condition of the bank. You can update data from the bank CSV. From that data, you can create 2 predictors. Okay, one is the total loans plus lease divided by assets. Yeah, so this is the ratio of the total loan and lease to total asset. The other one predictor is the total expenditure divided by assets. Total expenses to total assets. Yeah. Then we can build the logistic regression model. Okay, the outcome is a financial situation. The weak or strong. Yeah. The outcome just 2 values, 2 possible values, weak or strong. The first one is to ask you create the logic function. The next one is the odds function, probability function. Okay. Now we apply this logistic regression model on new data, new input. Okay, this new input has 2 values for 2 predictors. The one is 0.6, the other one 0.11. Okay, here we assume the cutoff value is 0.5. Okay, next 3 is to compute the threshold for the cutoff value 0.5. You just using the equations to convert the probability value to a logic value for the case 0.5. Okay, the other one 4 interpret the questions for the total loan and leases to total assets ratio. Yeah. And we also have questions when bank in a poor condition and is misclassified as financial strong. Yeah, how to minimize the repeated cost of misclassification. And we can change the color value. That depends on whether increase or decrease this color value. So we need to analyze the features of the logistic regression model. Okay, we continue the solution. And solution here. For this solution, we need to create a new file for the Python notebook. Before that, you need to import, because you can copy the import statements. Sorry, import statements. Yeah, it will be the same. Then you need to read load data. Yeah, so you can run one by one. So we have the data from bank CSV. Yeah. So we can see 1, 2, 3, 4, 5 variables. And we know the total cap assets, total expenditure assets, total loan lease assets. These two are predictors. Okay. Financial condition will be the outcome. Yeah, it can be strong or weak. So here we can see the strong all these cases are strong. Before the analysis, we need to change the name because the backward slash and the blank space are not good for the analysis. We have to remove the characters. And character, the blank space, backward slash. So we will do this. So we can check again whether there any change. Yeah, you can see the name already changed to underline. And we will remove some fields. We can remove the OBS fields and the total cap assets fields. So only leave 3 columns for the analysis and 2 predictors, 1 outcome. Okay. And so have the new data. Then we define the logistic regression model and train the model using the defined data. So before that, we need to define the data using the predictors and one outcome. Okay. So this is why. Yeah. We will not divide the data. We will analyze all the data. So we have the definition for logistic regression. We use the same parameters as an example. Then we train the model using the data. Then we print results of the questions and the RC score, the parameters. Okay. So we run this. So there are 2 questions, yeah, for the 2 predictors. Okay. And we have the intercepts. According to these values, we can obtain the logic value, odds value, and probability value. Yeah. So you can add a new statement. Sorry, it's not that case. Oh, sorry. The equation will be this, but the questions require me for the the equation will be this, according to the 3 values. So I just put to the document. Okay, now we create a new cell. We will create a new data frame from the input, from the condition of the questions. 2 values, 0.11, 0.6 for the 2 predictors. Okay. Then we apply the model to this new data. So we'll call the logic function, and also the odds function, probability function, to obtain 3 values. So it says the math function not available. So we need to import the math. Yeah, import the math. So we need to rerun this. Run this. Yeah. Now it's okay. Obtain a new value for the logic value, ask value, probability values. So the probability is 54.6%. So it's a high possibility to be 1. Yeah. The 1 is for the case strong. Oh, just wait. Oh, the success is weak. So 1 is weak. Sorry. The success is weak. You can see the success class is weak. So it's the dummy variable be 1 for the financial week. Yeah. And the 0 will be financial strong. Yeah. So the analysis result for the new case with the probability 54.57% is a weak case. Yeah, so the financial is weak. Okay, this is the solution for this lecture. Actually, you can answer other questions. Because just now we already analyzed this. We obtained the values for logic arts probability. Logic arts probability. Everyday financial to be weak, and the classification of the bank. The classification is Y, and so the probability is weak to be 54%. And logic value, art value also calculated. Okay, for the cut value 0.5, this is the probability value. You can convert to the logic value. Yeah, you can create a new cell because the P is 0.5. So we can obtain the odds value using this new equation. So we can print sorry. So the odds value is 1.0, and the logic value is Ln this odds value. Yeah, so logic value is 0. So this is the solution for this one, the third one questions. The interpreter the estimated questions for the two predators in terms of odds of being financially weak. The odds to be financially weak, that means the probability is higher than 0.5. As the higher p, the odds value will be higher. Odds value higher, the logic value will be higher. So according to this logic function, we know that the correlation, the two predictors will also be high. Yeah, if the other one predictor is one constant. Yeah. And the change of the total loan lease assets has a correlation 8.3713. This is for the logic function. Okay, the last one question. If one pool misclassified is strong, whether how to change the cutoff value. So that means we need to make the possibility to be strong become lower. So we need to decrease the cutoff below than 0.5. So more cases will be classified as weak. Then see the solution. Yeah, so we can decrease the cutoff below 0.5. Yeah, so be more cases will become weak. Okay, there's a solution for this lecture. And we have the stop for the next one. Thank you.